Two of the hottest topics of the moment, Steam Deck and Elden Ring. Well, they've kind of come together as a fascinating story unfolds, one that I had to spend some time digging into. So here's the thing, we've covered the PC port of Elden Ring already. It launched in a terrible state, but as PC owners struggled to get the game operating smoothly, within days of launch, Steam Deck was running it just fine, something that, in theory at least, shouldn't really be possible. After all, if we're witnessing stutter and even slowdown on PCs far more powerful than the Steam Deck, the game should be running very poorly indeed on the handheld. And to be fair, in its default state at launch it was. But here's where this story has some added spice. Valve has provided bespoke optimisations to the Proton compatibility layer, the software that translates DirectX 12 on Windows to Vulkan on Linux, utilised extensively by Steam Deck. I can confirm that the improvements were and are dramatic, but on a more global level, there are two key topics to address here. Number one, how did Valve improve Elden Ring on Steam Deck? What does the before and the after look like? And secondly, more generally, has Elden Ring on PC improved at all since we first looked at it? We'll be taking a look at that towards the tail end of this video, where from our testing there has been genuine improvement, but clearly there are some big variations in results here from our two test PCs, suggesting that there's still work to be done. Most of my time here talking about Elden Ring on deck because, I mean, this is the dream, isn't it? The concept of taking the latest AAA gaming juggernauts and running them on a handheld in a way that we've never seen before, without having to wait months or even years for a specific port to a bespoke handheld platform like Nintendo Switch. Steam Deck, after all, it's a PC, right? I ended up choosing settings that essentially use the medium global preset as a base, increasing anti-aliasing quality and decreasing shader quality, which per Alex's video does not actually seem to do anything whatsoever. Texture quality can go up to high with no real impact on performance. But here's the thing, you're unlikely to tell the difference on that small handheld screen. Still, for the purposes of comparison, high is what I went with. So we've already shown that the Valve handheld can run the game well, but here are some basic settings comparisons to get a grip on the basic capabilities of the deck with this title. I've taken a fairly demanding scene here and run it at flat low, medium, high and maximum settings, all at 720p resolution. The deck can run this game at 800p, but it seems that the game only supports 16:9 aspect ratios, so it's not really worth it, as you always end up with black borders top and bottom. Frame rate averages aren't particularly interesting as we're running unlocked and content varies dramatically, but even so, we're looking at 27.7 FPS on max, 30.3 on high, then a gap of sorts to 34.6 at medium and 36.6 at low. You're seeing the FPS readings playing out in real time here, by the way. You're seeing how static content can see performance shift, and not by an insignificant amount, hence adding the averages there. Adjusting all of this into performance differentials, there is some scalability here. Dropping from max to high gains you an average of 13% in this scene, rising to 25% from max to medium and 33% from max to low. But depending on content, the gap between low and max can widen to up to 45% in this scene. Again, it's the performance difference between high and medium that catches the eye. If you're looking for overhead to ensure consistent performance at 30 FPS, basing settings on medium seems like a good starting point, which is exactly how I approached my choice of quality selections, eyeing that 30 FPS cap which is provided adeptly by Valve via the Steam Deck's performance menu. So, I recently positioned Steam Deck as like a handheld PS4, and I think that comparison continues to hold up when you put my rendition of Elden Ring up against the PS4 version. Bear in mind here that this is the PC build of the game with Valve's optimisations in place. We'll talk about those enhancements shortly, but let's kick off by taking a look at how my Steam Deck setup compares with the last-gen console experience. The resolution difference is marked, obviously, but beyond that, it's clear that the handheld is competing very closely to the last-gen console presentation. There are some small differences in grass placement and tree shadow LOD, but ultimately very close indeed. 60 FPS or anything close to it is off the table on Steam Deck. I've already demonstrated that. So yeah, I have opted to use Valve's system level 30 FPS cap, smoothing out the experience via increased consistency and improving battery life in the process. And that's where this specific comparison proves intriguing. I'm going to start by showing the perennial From Software 30 FPS frame pacing problem on the last gen machines. Running through the PS4 version here, you'll see that 30 FPS is delivered, but looking at the frame timeline, you'll see that frame delivery hitches and stutters. 16.7, 33.3 and 50 millisecond frame times, when 30 FPS should be a flat, consistent 33.3 milliseconds. One new frame for every second display refresh. The difference is obvious when we cut to a PS4 versus deck performance comparison. Yes, the same poor frame pacing remains in effect on the console of course, but Valve's system level 30 FPS cap gets frame delivery right most of the time in general play. That's not to say it is perfect, however. Both deck and PS4 have issues, often in the same places, and it seems that pushing the GPU hard has an impact on consistent frame delivery, the smoothness of the game. We've got a match time of day here in the same environment, and it's possible to amass a bunch of opponents intent on chasing you down and killing you. Handling all of those enemies seems to be taking a toll on CPU, GPU, possibly both, and you'll note that both PS4 and deck are now struggling. Frame times are off beam, and while frame rates are similar between the two machines, the deck has more inconsistency, though to be fair, I'm counting more enemies in the immediate vicinity on that side of the screen. But still, there may be 9 years of technological advances between the two devices, but fundamentally Steam Deck is running at a fraction of the power budget afforded to the PlayStation 4 here. You'll also find that both systems can be entirely GPU limited too. Consider this encounter with the Flying Dragon Akil. Initially, as the beast descends, it looks like Steam Deck better holds its performance level. Quite the thing, bearing in mind the size of the entity here, the effects it's generating as it hits the ground, along with the presence of other beings on screen. However, once the confrontation continues, the monster isn't afraid to bring out the big guns, specifically its fiery breath. At this point, we can see that both PS4 and Steam Deck are entirely GPU limited, resulting in frame drops. PS4 seems a touch better here, but to be honest, it's a wash. We can't match content precisely here. Sometimes deck runs faster than PS4 too. But it's at this point where we really need to talk about the problems with the PC version of the game and how Valve has used its Proton compatibility layer and the advantages of the Steam Deck as a single fixed platform to improve performance. All of the deck footage I've shown so far has been of the game running a rendition of Proton that mitigates issues discovered by Valve. But how did the day one code look on the handheld before the fixes were added? Hold on to your hats here because things are about to get rather gnarly. I mean, starting the game with the Steam Deck's system level 30 FPS cap in place, well, initially things look absolutely fine, right? This kind of consistency in performance is still a step up over the last gen console versions of the game. But then we encounter stutter like this. Yeah, that's about 370 milliseconds right there, encountering the first boss, Grafted Scion. Further stutters occur in the same fight, effectively making the launch experience unplayable on Steam Deck. Here, even the simple act of striking out with the sword, killing an enemy and kicking off a minor physics interaction also caused some stutter in that initial day one build of the game. And yeah, more instability here, just, well, walking up the staircase. But the further you played into the game, the more problematic the issues became. So yeah, just wandering about here at the opening areas of Limgrave, and well, this was a hardly optimal state of affairs, right? Obviously, any kind of playable confrontation with the Tree Sentinel here was not on the cards. I mean, I could go on, seriously, I could really continue showing you the various slowdown issues I encountered of various shapes and sizes based on the frame time graph at least, but suffice to say that the game's outstanding issues combined with the hardware and software makeup of the deck create a pretty disastrous turnout. But the point is really that Valve did fix the problem and did so ahead of further Elden Ring patches from the developer. And to properly test this, we needed to completely remove the game from storage and re-download it to ensure that any pre-cached data from my first run here was entirely removed. And to further double check the integrity of Valve's fixes, I also tested Elden Ring with another fresh install to a completely different storage device. I mean, we've already discussed performance with Valve's changes in Play. We've discussed how it compares quite favourably with PlayStation 4, in fact. And actually, if we take a look at what's happening on the Microsoft Xbox One S, well, it's gaining extra resolution over Steam Deck, but it's running with drastically reduced quality settings and some truly awful performance based on this excerpt from Tom's last Elden Ring video. That's remarkably bad stuff right there. Steam Deck, a handheld. It's not perfect as we've seen, but by comparison, it's simply great. So yes, there are hits to frame rate with overtly heavy effects work, but the traversal stutter is gone. Returning to the Tree Sentinel scene here, there are dips, but I'm inclined to think it's GPU based here, as opposed to anything more deeply problematic. Ultimately, we are pushing a 15-watt AMD APU pretty hard here, and it seems that bandwidth-heavy GPU effects can still be challenging for the hardware. Now, we're going to talk about later patches to Elden Ring shortly, but in my testing, Valve got it right, and actual From Software patches since then haven't really changed the situation that much. So how did Valve deliver such dramatically improved performance? We've seen some comments on GitHub commits, but to put it all into context, I asked Valve for an overview. First of all, shader compilation issues. Well, this is stutter caused by the CPU compiling GPU shader code as it's needed, but in the middle of gameplay, interrupting the flow of play. With so many different PC GPUs out there, shaders can't be packaged up in the same way that they can be on consoles. But Steam Deck is similarly a fixed platform. Here's what Valve has to say about what they can do with their hardware. On the Linux/Proton side, we have a pretty extensive shader pre-caching system with multiple levels of source level and binary cache representations pre-seeded and shared across users. On the Deck, we take this to the next level since we have a unique GPU driver combination to target, and the majority of the shaders that you run locally are actually pre-built on servers in our infrastructure. When the game is trying to issue a shader compile through its graphics API of choice, those are usually skipped, and we find the pre-compiled cache entry on disk. Now that's very nice, but we have discovered that tuned high-end DDR5 desktop setups also seem to have fewer stuttering issues. The game has other problems, as Valve explained to me in a bit more depth. Shader pipeline-driven stutter isn't the majority of the big hitches we've seen in that game. The recent example we've highlighted has more to do with the game creating many thousand resources, such as command buffers at certain spots, which were making our memory manager go into overdrive trying to handle it. We cache such allocations more aggressively now, which seems to have helped a ton. I can't comment as to whether this is the problem the game experiences on other platforms as well, but we've been playing on Deck with all these elements in place, and the experience has been very smooth. And yeah, I think my own testing bears this out, right? When you go from this to what is effectively a fairly decent hold on a consistent, properly frame-paced 30 frames per second, what you end up with is a fully viable handheld rendition of Elden Ring that is plumbed in to the Steam ecosystem, meaning that if you also play on a desktop PC or gaming laptop, Steam cloud saves ensure that your progress is mirrored on other devices. What I also like about the Steam Deck is the flexibility of the platform, which is to say the strength of PC gaming generally. You're in control. Let's go back to those settings comparisons. On the face of it, the big ticket increase moving from the low and medium settings to high and max is more grass, right? A richer world. This is the PC version of the game. We can just turn it on and see what happens. Perhaps not surprisingly, the consistency in 30 FPS is compromised, but maybe we can trade some resolution for that. Maybe some of the less impactful settings can be dialed back in order to give the GPU the headroom to let you keep that richer world. We've often talked about the Nintendo Switch's screen mitigating a lot of graphical issues that are much more problematic when docked, when you're viewing those issues on a huge screen. And, well, similar principles can be applied here. So what I've done here is a straight trade of pixels for features. Internal resolution drops down to 540p with system level fidelity effects super resolution, FSR, upscaling us back up to 720p. It's not quite super solid at 30 FPS, but we're demonstrating here that we do have flexibility, and on the handheld screen, it's not a write-off image quality-wise. And yeah, of course, there's nothing stopping us simply using FSR with the existing settings for a battery life boost. Okay, so look, we wanted to talk about the state of the PC version in general, and as I said, these Steam Deck comparisons were carried out on patch 1.02. Not that there was much improvement with 1.02.03, but here's the state of play on PC with the new patch installed, with data provided by Alex on his Core i9-10900K system with RTX 3090, running at 4K resolution at high settings, where we still have issues, and my own 10900K system, same settings, but running with a 3080 Ti instead. The good news is that there is some improvement. Much of the stuttering we saw has been reduced in terms of frame times, which is a good thing, and Alex reckons that in general there are fewer stutters on his system. To ensure that all pre-cached data was removed, and that we were looking at a like-for-like scenario, we used DDU to remove the graphics driver, completely reinstalled the game and deleted all cache and save game folders. We effectively nuked the game from orbit, as it's the only way to be sure. There's no prior cached data, making it look as though the game has improved. So good news so far for Alex's test setup, but well, stutters like this that literally freeze the action for circa 735 milliseconds, like almost 3/4 of a second. That's really not great. But here's where things get a touch confusing, because running through the same areas of the game on my own test PC, I got a very similar experience, but without those gigantic game-breaking stutters. There are still some dropped frames, but not enough to unduly impact the quality of the experience. If I hadn't seen Alex's test data first, I would have said that Elden Ring PC is fixed. But when we have two contrasting experiences on what are effectively two very closely matched PCs, it suggests that there may still be issues. And no, I don't think it's the difference in GPU that is causing Alex's problems here. After all, 3090, 3080 Ti, it's the same silicon, it's the same driver, and my GPU actually has a touch less compute and a lot less RAM. So for me at least then, a big improvement overall. But when you look at Alex's results, perhaps it's the case that PC performance problems have yet to be fully addressed. But in the meantime, that's it. That's everything from me. Like, subscribe, share if you enjoyed the content, and ring the bell for those notionally instant notifications when new DF content drops. DF Supporter Program. Join us for pristine quality downloads, Discord access, early access to content, and more. I mean, the PS4 versus deck data contained in this video went up a week early, but there's always cool stuff going on. But yeah, thanks for making it all the way to the end of this one, if indeed you did, and just generally thanks for watching and supporting Digital Foundry.